Hello everybody, it's Mrs. Pound and we are currently studying Chapter 9 on chemical compounds from BJU Chemistry's 5th edition. Today we're going to take a look at section 9.1b, and this is naming ionic compounds. In our last video, we took a look at how to write the formulas for ionic compounds. So our objectives today will be to name ionic compounds when given their formulas, write formulas for ionic compounds when given their name, and explain the significance of the Roman numerals in some ionic compounds. So when we're naming things, it's called nomenclature, and this is a system of naming compounds developed by the International Union of Pure and Applied Chemistry, which is abbreviated as IUPAC. So let's first take a look at binary ionic compounds. And remember, these are ionic compounds that only contain two elements. When we name binary ionic compounds, the positive ion is just given the name of the atom. And the negative ion receives the IDE ending. So for example, when I have CaI2, we take a look at the first atom. It's a metal. We simply name that calcium. And then the second one, the I, is iodine. So we change the ending to IDE, so it becomes iodide. So we have calcium iodide. In KBr, K is potassium, so we just leave the name the way it is. Br is bromine, so we change that to an IDE ending, and it becomes potassium bromide. Now, let's go the other way. If we have hydrogen sulfide, hydrogen is just capital H. Sulfide, that sounds a lot like sulfur, so that is an S. But remember, we now have to take into consider the oxidation numbers. So hydrogen, +1 oxidation number, sulfur, -2. So we do the crisscross, and we get H2S. Sodium hydride, we have sodium. Hydride, remember, is hydrogen. So we write the symbols with the oxidation numbers. Sodium is in the first group, so it's a +1. Hydride is -1. Here is where we have hydride. It's negative for the hydrogen. When we name it hydrogen, it's +1. So we crisscross, but these are just ones. So we end up with NaH. Now remember, when you're writing these formulas, the A on sodium must be lowercase. Otherwise, if you put it as a capital A, it's indicating that you're starting another element, and that's not true. Now let's take a look at the polyatomic ionic compounds. So when we use these, get out reference table E, which I have a picture of right here. When we're using polyatomic ionic compounds, we name the cation and anion like binary ionic compounds. So if it's just one element, it's the same rules as the binary ionic compounds. So let's take a look at NH4Cl. Oh, I have 3 different elements, so that means I have a polyatomic somewhere. So the polyatomic is this NH4. So I find it over here in table E. Right here, NH4 is ammonium, so I name that ammonium. And then we have chlorine, and it's at the end, so I change it to IDE ending. So this is ammonium chloride. KNO2, ooh, 3 elements, so that means I have a polyatomic somewhere. So I know that it's NO2, but you could search for KN, and if you don't see it in your chart, then you would search for the NO2. And I see the NO2 right here which is nitrite. So K is potassium, so it's just the atom name. NO2 is nitrite. So this is potassium nitrite. Here, this is pretty nice because we have the parentheses. We know that this is the polyatomic. We have calcium out front, so that's just its name, calcium. We look up ClO3. So, we got a lot of ClOs here. These, we have to be careful then. We have to make sure that we have the one with the 3 oxygen, which is right here. It's chlorate, ClO3 negative. So this is calcium chlorate. Then ammonium hydrogen sulfate. So I see ammonium and I remember that. So we're going from the name to the formula now. So ammonium is NH4 positive, so I'm going to write that down on my paper with parentheses. And then I have hydrogen sulfate, which I look up right here, HSO4 negative hydrogen sulfate. So I write that also on my paper with parentheses. And I get this. So NH4 positive in parentheses, HSO4 negative in parentheses. I do my crisscross. And because the ones, we don't write them, it's just NH4, HSO4 with no parentheses. Now let's take a look at barium hydroxide. So barium is just Ba. Hydroxide. Hydroxide is over here. It is OH negative. So I write down my oxidation numbers, Ba2 positive because it's in group number 2, barium is. OH negative in parentheses. I do my crisscross and I end up with BaOH2. Now, oxyanions, this is an anion composed of oxygen and one other element, such as sulfate, SO4 negative. These were also, when you saw on the chart, the different ClOs, which ClO3 was chlorate. Those are all oxyanions, and we have to be careful with those because there's usually multiples of them, and they do have different names and possibly even different oxidation numbers. So you have to be really careful with those. Now let's take a look at the stock system. This is used when we have metals with more than one oxidation number, mainly the transition metals. So this is what we use when there's a transition metal. We write a Roman numeral after the element's name to show its oxidation number, not the number of atoms, the oxidation number. So just as a reminder, here are your Roman numerals. So copy these down so that you remember these in case you've forgotten. These are capital letter I's here. So 1 is just a capital letter I, 2 capital letter I's, and so on and so forth. Remember, for 4, you put the I out front, and it means to subtract 1 from the V, which is 5. And the same thing with 9, you're subtracting 1 from the X, and the X is 10. Otherwise, for 6, 7, and 8, if it's after, you add it to the 5. Okay, so that's just a quick review of Roman numerals. So an example here is Cu2O. So what we're going to do with this is we uncrisscross. We have to get back to the oxidation numbers. So when we uncrisscross, the positive 1 comes up here to the copper, the negative 2 to the oxygen. Remember, the first element is always positive. The second one is always negative oxidation number, okay? And so when we do this, it's copper 1 because the oxidation number is a 1, oxide, IED ending. Here we have Cr2O3. So we do the same thing. We uncrisscross. So it becomes Cr3 positive because the first one is positive. O2 negative, the second is negative oxidation number. So when we write this, this is chromium. Cr is chromium. the oxidation number 3 positive, it becomes Roman numeral 3, and oxygen, we change it to an IDE ending, and it's oxide. Here we have a polyatomic ion. So we look up C2H3O2. We see it right here. It is acetate. So we uncrisscross, which gives us Fe3 positive, acetate with a negative. So this is iron, because Fe is iron, 3 in parentheses from the oxidation number, acetate because that's the polyatomic ion. Let's take a look at manganese 2-phosphate. Now this is nice because we know the oxidation number here for manganese. It's going to be a 2 positive. Let's look up phosphate. Phosphate is PO4 3 negative right here. PO4 3 negative. So we have Mn 2 positive. In parentheses, we put our PO4 3 negative. We crisscross, and we end up with Mn3 PO4 2 with the with the 2 outside of the parentheses. Okay, how about titanium 4 oxide? So titanium 4 oxide. Titanium, we have the oxidation number. Oxide, we've been using that a lot, so 2 negative. So Ti4 positive, O2 negative. We crisscross, and we end up with Ti2O4. But remember, with ionic compounds, we have to reduce it to lowest terms. So we write it as TiO2. That's just a reminder of reducing things. We don't have to do that too often, but we often do have to do it, especially with oxygen when we're using group 2 for that as well. And hydrates. A hydrate is a compound that holds a fixed amount of water in its crystalline structure, and we indicate that in its name. We use Greek prefixes for the number of water molecules. So here's a reminder of your Greek prefixes. 1 is mono, 2 di, 3 tri, like a triangle, 4 tetra, like the game Tetris. All of the shapes in Tetris have 4 blocks in them. 5 is penta, like pentagon. 6 hexa, like hexagon. 7 hepta. 8 octa, like an octopus that has 8 legs. 9 is nana, and you can kind of see the number 9 in that. And 10 deca, like a decade has 10 years. So let's take a look at a series of naming some hydrates. And we're going to start with Na2CO3. So Na2, that's just Na is sodium. CO3 is one of our polyatomics, so we'll look it up over here. And it's right here. It is carbonate. So this is sodium carbonate. And we say that this is anhydrous. And sometimes you'll even see this on chemical labels. It says anhydrous. What anhydrous means is no water. Okay, we're going to take the same thing, sodium carbonate, and we're going to put water on it. There's only 1 water here. We don't write the number 1 out in front of it. So this is sodium carbonate monohydrate because there's 1 water in the formula. We're going to stick with the sodium carbonate idea here, but now we're going to have 7 waters. So that prefix for 7 is hepta. So this is sodium carbonate heptahydrate. The hydrate is what we write for the water because it's hydrated. Just like when we hydrate ourselves, we drink water. So sodium carbonate again, this time 10 waters. The prefix for 10 is deca, like decades. So sodium carbonate decahydrate. Then we have cobalt 2 chloride hexahydrate, and I want you to write the formula. So we focus first on the first part, cobalt 2 chloride. We know the oxidation number is 2 for the cobalt. And we know that chloride is a halogen, and group 17 is always -1. So we have CO2 positive, Cl negative. We crisscross to get CoCl2. But let's not forget the hexahydrate. Hexa means 6, so we have 6 waters. So this is the formula for cobalt 2 chloride hexahydrate, CoCl2 with this dot and 6H2O. So our objectives today were to name ionic compounds when given their formulas, write formulas for ionic compounds when given their name, and to explain the significance of the Roman numerals in some ionic compounds. Don't forget your 5 questions in the margin, and we're going to be practicing these in class.